Hi friends, welcome to my channel NM Learn My Courses with Nagamani. Today I am going to explain about these short notes formulas, and here they are giving first it is started with the matrix multiplication. So here they are giving A matrix which having M by N order and B matrix having P by Q order. So this order which is nothing but number of rows in that matrix and number of columns in that matrix. So I will explain this with this simple example. Okay, so if you see here they are giving A matrix having M by N order, B matrix having P by Q order, and first is when the matrix multiplication of AB is possible. So and also they are given one condition. So if we want to multiply A into B, then this number of columns in first matrix which is equal to the number of rows in the second matrix. The condition for the matrix multiplication of A and B is number of columns in first matrix which is equal to number of rows in second matrix. This is the condition, and if we multiply, then if this condition is possible, then the matrix multiplication is possible A and B, and which having order M and Q, that is M by Q. This is the first one. And if we see the second one, if we want to multiply B with A, then if we want to multiply B and A, then B matrix, first matrix, these columns which is equal to the second matrix rows, that is nothing but Q equal to M, then only B by A, like B into A multiplication is possible, which having the order P by N. So P by N, this is the condition which I have given here. If you want this one, I will explain with the example. I will give one example. So first one is A having 2 by 3 matrix and B matrix having 3 by 2. So here number of rows, like number of rows is 2 and a number of columns is 3, and in B matrix number of rows is 3, number of columns is 2. Okay, so if you see here, if we want to multiply A and B, we have to check one condition, that is whether number of columns in the first matrix which is equal to number of rows in the first matrix. We have to check that one. So if you see here, here 3 and 3, so these are same. So we'll get A B multiplication which having 2 by 2 order. Okay, this one, and we can, so that here A and B matrix is possible, and we also check B into A matrix. So for this number of columns in the first matrix, so first matrix which is equal to number of rows in the second matrix. So here also 2 by 2 is possible. So we will get B by A having 3 by 3 order. So A by B, like A into B multiplication is also possible, and B into A multiplication is also possible. This is the condition to check whether the A and B multiplication is possible or not. So these are the two conditions for checking A and B multiplication of matrix. Okay, and here some of the properties are given for the A multiplication of AB matrix, and here it is say that a matrix multiplication is not commutative, that means A into B which is not equal to BC, and matrix multiplication is associative, that means if they given A and B and C matrix, then A of BC which is equal to AB into C matrix, that means matrix multiplication is associative. And also AB equal to 0 which need not implies A equal to 0 or B equal to 0. That means if they if the matrix multiplication of two matrices are 0, then it doesn't mean any like A matrix is 0 or B matrix is 0. That means A and B or need not to be a null matrix for getting multiplication of this matrix equal to 0. Okay. So if we see the fourth point, they are giving A and B matrix, and this product which involves number of multiplications as M n p and number of additions which involves mp into n minus 1. That means, okay, here I will explain with the example. So in exam they will give A by matrix is 2 by 3 and B matrix is 3 by 3 matrix. Like simply I am giving, this is an example. They will change the order of A and B matrix, okay, and they will ask, if they ask number of multiplications in this matrix, then the formula is this first number of rows in A matrix and number of columns in the B matrix, and here the same one is 3 by 3, no? So 3. So this is 3 3s are 9, 9 2s are 18. So 18 is the number of multiplications present in the A by B matrix, okay. And if they ask number of additions present in the A and B matrix, which is nothing but this is for number of multiplication, okay, number of multiplications. If they ask number of additions present in the A and B matrix, then the formula is this one only. So like a first like a number of rows in the first matrix and a number of columns present in the second matrix into, here 3 is there, na common one, so 3 minus 1, that is nothing but 2. So this is the number of additions present in the A by B matrix. So 2 2s are 4, 4 3s are 12. So number of additions present in the A and B multiplication is 12. Number of multiplications present in the A and B matrix is 18. In this way you can do the any problem, okay. So in this way, this is the fourth point, meaning. And in this here I wrote trace of A, which is nothing but sum of the principal diagonal elements. That means if we take this A matrix, sum of the principal diagonal elements means 1 7 and 11, like 1 plus 7 plus 11, which is equal to 11 plus 7 is 18 and 1 19 is the trace of this matrix, okay. In this way you can find the trace of the matrix, and here some of the properties also given. So these properties are important for the competitive exam. So if you see here, trace of the A matrix, which is equal to trace of A transpose matrix, and a trace of A, like addition of A and B or subtraction of AB, which is nothing but trace of A plus trace of B. Okay, this one I will explain with the example, okay. Okay, if you see the example, they are given A matrix is 1 2 3 4 5 6 7 8 1, anything, like I am writing, simply I am writing this is the A matrix, and they are also giving B matrix, like they, okay, this is the A matrix. If they are asking trace of the A matrix, then this is nothing but sum of the principal diagonal elements, that is nothing but 1 plus 5 plus 1, which is nothing but 7, okay. In this way trace of the matrix can be calculated. And also in exam they will ask, like they will give AB, like a multiplication of AB matrix, which is equal to 5 6 1, like 2 3 4 5 4 1. So they will give AB matrix, and they will ask to find trace of BA. So if we know the properties, like in generally we will find, first we will multiply with B and A, or if they give A B matrix as separate, then we will multiply with B and A, then we will find the trace of the matrix. But if we know the properties, like so the trace of the A matrix, trace of any multiplication matrix, which is equal to trace of reverse of matrix. So here trace of AB is nothing but this is 5 plus 3 plus 1. So 5 plus 3 plus 1, which is equal to trace of BA. So trace of BA is 5 plus 1 is 6, 6 plus 3 is 9. So the 9 is the trace of BA matrix. In this way you can find the trace of the matrix. And also there is one more property is there, that is they will give A matrix and B matrix. Okay, they will give A matrix and B matrix 1. So we need only middle one, 2 3 5. So if you see, they will ask trace of A plus B matrix, then just add trace of A plus trace of B. No need to add and no need to subtract that matrix. So trace of A is 1 plus 5 plus 7. So 6 13. So plus here 5 plus 3 plus 2 10. So trace of A plus B is 23. If they ask trace of A minus B, then just keep here. So if they ask trace of A minus B, then he use here minus. So 13 minus 10 is 3. So trace of A minus B is 3. In this way you can find the in exams if they ask. Okay, so this is the about a trace of the matrix. And if you see here, they are given upper triangular and lower triangular and diagonal matrix. Like how can we identify these matrices here? So these are the condition for the upper triangular and lower triangular and diagonal matrix. So upper triangular means only upper elements having numbers, and lower triangular means only below diagonal elements having numbers. Okay, just for remembering purpose I am telling you in this way. Okay, so upper triangular means only above diagonal elements having non-zero elements, and lower triangular means after, like in lower diagonal only having numbers. This is the example for lower triangular, this is the example for upper triangular. And diagonal means like only diagonal element will be present. Okay, this is up to this side of matrix part. So here we learn how the matrix multiplication is possible, and rules for matrix multiplication, and some of the properties for the matrix multiplication, and if the matrix multiplication is possible, then how to find the number of multiplications and the number of additions, and the properties for the trace of the matrix, and how to identify the upper triangular matrix and lower triangular matrix and a diagonal matrix. And we will see some of these other rules in the next coming video. And thank you for watching. If you like the video, please like, share and subscribe to my channel. Thank you.